Hello and welcome back to our series on applying machine learning to a real-world dataset. We are building a neural network to predict which JIRA issues will become problems. In this episode, it's time to build and test the neural network, and then we'll use it to make real predictions. Let's get started. Okay, we're up to the bit where we actually create the neural network, and it's not that hard to do with scikit-learn. We'll go up to the top here and add a few libraries to help us. The first one that we'll import is an actual neural network model. It's scikit-learn.neural network, and we want to import the multi-layer perceptron classifier, which is MLPClasifier. That will be our model, and then when it's done running, once we fit data to it and we're testing it, we're going to want to get some metrics on how well it performed, and we can get a thing called a classification report from sklearn.metrics import classification report. Now we can jump right back down to our code and start using those things. So we'll create a new section here. We'll call this create neural network, a new line, and we'll call this neural network MLP. It will be an MLP classifier object. And there are a number of interesting options to explore on this object. We're just going to use two of them though. We want to adjust the hidden layer sizes. The way I want to set this up is with one hidden layer, and the number of nodes that it has should be halfway in between the number of inputs that we're feeding in and the output that we're getting. To do that, I can use the hidden layer sizes parameter. Hidden layer sizes. I'm going to set it equal to, I want the number basically of independent variables divided by 2. So I will take the length of my ivars, and maybe I'll add 1 to it to represent the dependent variable, and use floor division to divide that in half so that I end up with an integer. And then the other parameter that I want to work with is max iterations, and that's max iter. And the default here is 200, and I often find that is just not enough. So I'm going to boost it up to 2000, which should not be a big problem for us because we have a fairly small data set here. Now, with our classifier created, we can actually train it with our training data, and the way to do that is fit the data into it. So we'll call mlp.fit, and we'll pass in our training data. That's xtrain and then ytrain. Now, ytrain is a single column. And actually what this function is expecting is an array. So I'm going to unwrap the values that are in this object and present them as an array using the ravel function. And with our model trained now, we can use it to make some predictions. And the very first predictions we should be making are the ones against our test set, because we already know what the actual output should be there. So I'll create a thing I call test predictions, and that will equal mlp.predict. And we will pass in our test data like that. When we're done making those predictions, I want to compare them to the actuals. So I'll use the classification report for that. I'll print classification report. And what we're looking at now is our Y test data. Those are our actuals versus our predictions, which are stored in test predictions. That looks pretty good. Let's see how it runs. Let's see, do we have errors at the top? We do. Okay. sklearn metrics import classification report. There we go. Run all. Okay, right on down, and through we go. Now this classification report gives us several metrics here that are very interesting and tell me that the model is performing very well. Precision and recall are the two that we pay a lot of attention to. Precision is basically the proportion of positive identifications that were actually correctly predicted by our model. The mathematical way of thinking is true positives divided by true positives plus false positives. So what it's really saying is when our model predicts an issue to be a red flag issue, it is correct this % of the time, 100% of the time. That's nice against our test set. And then recall, that is the proportion of all actual positives that were identified correctly. So that's everything that was a positive in our test set. Did we catch them all? Mathematically, that's true positives divided by true positives plus false negatives. So our model correctly identifies, again, 100% of all red flagged issues. So it appears we have a working model. Now what I think we'll do is use it to make some real predictions. So we'll create a new line here, give it some markup, and say make real predictions. New line. And the way we'll do this, we'll call this same predict method, but we'll pass it in a different set of data. I'll call this real predictions equals MLP.predict. And we'll pass it in that XP set of data that we have. When this comes back, what I want to do is take these real predictions and use them as a mask to go into our df not done data set and pull out those rows. In fact, pull out the indexes on those rows, because the indexes that we've been using are the ticket numbers, and that'll tell us which tickets are red flagged. So I'll create a mask of these, and that'll be map boolean from real predictions. And it'll have to be a list to list. When we're done, then I'll use that mask to query df not done and dump everything into a new data frame that I will call df red flag issues equals a pandas data frame from df not done dot lock, use my mask, and when we're done with that, I want the indexes and I want their values, because those are ticket numbers. That looks good. The last thing to do then would of course be to print it out. So copy, paste. Let's run it. And that's it. These are the tickets that are predicted to be red flag issues for us. And thanks to pandas, this df red flag issues, being a data frame, can be exported into many different formats like Excel, CSV, SQL. You can turn it into an HTML table and many more things. It all depends on what you want to do next with this information. And that could be the end of our story right there. We built a machine learning powered tool to improve our operations. But you know, this is kind of a black box. We can't tell managers why it picked these tickets. They are still forced to be reactive. They just have an early warning system so they can react a bit earlier. And I'd like to understand and be able to tell them what factors led the neural network to pick these tickets so the managers can be proactive and build programs to address the underlying causes of these things. So I'll post a follow-up bonus episode that dives into this problem, the problem of identifying the most important features in our dataset. That's called feature selection. I think it'll be pretty fun to do. So click the subscribe button to keep up to date. Thanks for watching. Bye.